Hello students, welcome to DEY'S Learning. In this video, we will solve one MCQ question on Ionic Equilibrium chapter from NEET 2020 paper, right? So let's start. You see the question on the screen. The question is, find the solubility of nickel hydroxide in 0.1 molar sodium hydroxide solution, and the ionic product of nickel hydroxide is given, right? See, we have to find the solubility of nickel hydroxide in sodium hydroxide solution, right? Sodium hydroxide is a very strong electrolyte, so we can write sodium hydroxide dissociates completely into Na plus and hydroxide ions, right? So the concentration, so the initial concentration of sodium hydroxide, is 0.1 molar, right? So initially Na plus and OH minus was absent, and after dissociation we can write concentration after dissociation, right? Concentration after dissociation. Concentration after dissociation, it will be of course 0.1 molar Na plus and 0.1 molar oxide, because sodium hydroxide completely dissociates into its ions. Okay, now nickel hydroxide, we can write nickel hydroxide, it is a very sparingly soluble salt, so it remains equilibrium with its ions, that is Ni2 plus and 2OH minus, right? And of course all are present in aqueous solution. Let the solubility of nickel hydroxide is capital S. I can write solubility, it is solubility of nickel hydroxide, of course in molarity, is S. If the solubility of nickel hydroxide is S molar, we can write the concentration of ions, right? The concentration of ions. The concentration of ions will be, this one is S and it one will be 2S, right? Now look very carefully. This concentration of hydroxide from nickel hydroxide is 2S, but hydroxide also comes from sodium hydroxide, right? So the total concentration of hydroxide will be of course 2S plus 0.1, right? This 0.1 molar comes from this sodium hydroxide, right? Now another very important point is this one, we can write this one is almost equal to 0.1 molar, right? Because this solubility S can be neglected with respect to 0.1 molar. Question is why? Now we can explain this one in a very simple manner. Look, the ionic product of nickel hydroxide is given in the question, okay? And this ionic product is, and we can write the ionic product, is equal to concentration of Ni2 plus and concentration of hydroxide whole square, right? 2 hydroxide ions is present there, so concentration Ni2 plus into concentration hydroxide, this one is the ionic product of nickel hydroxide, and of course this value has been given as 2 into 10 to the power minus 15, right? Okay, so this is equal to concentration of nickel 2 plus and concentration of hydroxide 2 minus, right? Now we can clarify the concept why the 2s factor has been neglected from here. Okay, see, हमें ये concept को थोड़ा experimental point of view से समझ लेते हैं, right? Look, this is a test tube, okay? and this nickel hydroxide, look, what is the solution? Nickel hydroxide is a very sparingly soluble salt. So nickel hydroxide becomes nickel hydroxide is an insoluble salt. Look, nickel hydroxide is a very sparingly soluble salt. So this salt becomes look, nickel hydroxide is a sparingly soluble salt, so it gets precipitated very easily, and look, nickel hydroxide is a very sparingly soluble salt, so it is dissolved in the aqueous solution in a very little extent, and most of the compound get precipitated from the solution, right? Ni2 plus Ni2 plus and hydroxide minus, these ions are present in the solution in a very little extent, and the product of the concentration of these ions in the solution is known as ionic product, right? This part is not the solution of the problem. I am trying to clarify the concept why the 2s term can be neglected with respect to the 0.1 molar concentration, right? Let the solubility of nickel hydroxide in absence of sodium hydroxide, in absence of NaOH is say S prime, right? So we can write from here, look, this one is S prime, this one is 2S prime, so the ionic product will be S into 2S. We can write the ionic product will be S prime into 2S prime whole square, and this will be equal to 2 into 10 to the power minus 15. Okay. So this gives us 4s prime cube. This one is 2 into 10 to the power minus 15, right? So s prime, this one equal to say cube root of half into 10 to the power minus 5, right? This one is molar. Sure. And if we solve this one, cube root of 2 is around 1.25, so I can write this one is 1 by 1.25 into 10 to the power minus 5, right? This one is molar, and 1.25 means 5 by 4, that is 4 by 5, right? So this is 4 by 5 into 10 to the power minus 5. So this is actually 0.8 into 10 to the power minus 5 molar. Say this is the solubility of nickel hydroxide in absence of sodium hydroxide, right? So the value of S prime is in the order of 10 to the power minus 5, right? So this 10 to the power minus 5 term can be neglected with respect to 0.1, right? So you will find this concept in many problems where the solubility of the sparingly soluble salts can be neglected with respect to the concentration of the strong electrolyte, right? So we can write this one as 0.1, as this term is very smaller with respect to this 0.1 molar concentration, right? And on top of it, in presence of sodium hydroxide, its solubility becomes further decreased. Okay, so we can obviously neglect this portion with respect to 0.1. Okay, now let's back to our problem, right? There is not much left in this problem. It is very simple, 2 into 10 to the power minus 15. So the concentration of the solubility of Ni2 plus is S. So this one is S into 0.1 whole square. So this one is 2 into 10 to the power minus 15. This one is S into 0.1 means 10 to the power minus 2, right? So capital S equal to 2 into 10 to the power minus 13, right? This one is molar. So this is the answer of the problem, right? So the correct answer of this problem is option A, which is 2 into 10 to the power minus 13 molar, right?